Just see, for a instructions in 8085, what are the three steps? Step is nothing but a fetch, decode, and executions. Fetch, decode, and executions. Fetch, decode, execution, fetch, decode, executions, fetch, decode, executions. Sir, why I am mentioning 1, why I am mentioning 2, why I am mentioning 3? Because these 3 for instructions 1, these 3 for instructions 2, these 3 for instruction 3. Every instruction have 3 different states. One is a fetching, another is a decoding, another is a execution. So what are the functions of fetching?
Sir, একটা জায়গা থেকে আর একটা জায়গায় আনা।
No. Fetching, no. Fetching for the instructions I already explained you. Fetching just what is your name? First you listen and it is stored. It's called fetching. First you listen and it's stored. It's called fetching. Decoding means, sir, asking my name means you are converting in your own language. It's called decoding. And next, my name is Dr. Sudipta Chakraborty. So this is the executions, right? So every instruction have 3 states: fetching, decoding, execution, fetching, decoding, execution, decoding, execution. And one should be done after another. One should be done after another. Right? Hello. Good afternoon. Yes. Yeah, you call me after 1 hour. I am in a class. Fetching, decoding, execution, fetching, decoding, execution, and fetching, decoding, executions. One after another. One after another. That's why 8085 is called sequential IC. That's why 8085 called sequential IC. Means one job is done, then the second job. This decoding is done, then the executions. These after this execution, second instructions fetching will be done. Then decoding, then executions. Means one after another. Is it clear? Is it clear?
Yes, sir. Yes, sir.
So this is done in 8085. That's why 8085 is called sequential IC. That's why 8085 is called sequential IC. Is it clear? It's clear?
Yes, sir.
In 8086, what is happened? Fetching. Next is fetching. Next is fetching. So fetching 1, fetching 2, fetching 3. And the second part, that is decoding and executions. Decoding and executions. Decoding and executions. 2, this is 3. Up to this means these 2 job is done in 8086. So these 2 block time will be saved for 3 instructions. Am I right?
No, sir.
Yes, sir.
Means fetching is done and decoding execution is done parallelly. When the fetching instruction of instructions 2, and in that particular time, decoding of the instructions 1 is, simultaneously done. Right? So this time is not required for 8086. Means this is the same time for 8086, which is required in 8085. but it's not required in 8086. This job, that's why 8085, 8086 architecture are dividing into the two parts. This job is done by BIU, full form bus interface unit. This portion is done by EU, full form execution unit. So this portion is done by BIU, this portion is done by EU, execution unit. So architecture basically dividing into the two parts. One part is called BIU, another part is called EU. It's called bus interface unit, it's called execution unit. So bus interfacing unit is done only the fetching, and execution unit is done only the decoding and executions. Now you have maybe the questions like, sir, if decoding done in this line and executions will be done in the next line, so then the time durations will be reduced. Am I right?
Yes, sir.
Yeah, it is done from 80286 and onward. It's done from 80286 and onward. Whenever 8086 is, created in that particular time, up to that is done. Okay.
Okay.
Next, I have one question to all of you. Whatever I am given an example of story, like you carry the table and put it in the outside from the room. Am I right?
Yes.
So this job is done by the Devajyoti. So next job is done by Subhra, and after the Subhra, who will be the next persons?
Amit.
Amit. Very good. So Amit will be, insert the material. Which one first? Table, almirah, which one?
So table.
Table.
The one that is
Means we can conclude which are in a first out, that will be first in, means first in, first out.
Yes, sir.
Is it clear or not?
Yes, sir.
yes, sir.
Yes, sir.
So you can say in the outside of the room there is a queue. In the outside of the room there is a queue where all the data is stored, right? Is it clear? There is a queue outside of the room.
Sir.
In this queue, all the data will be stored. So in 8086, there is a 6-byte long queue, 6-byte long queue, which is basically store all the fetching data. All the fetching data will be stored. That's why in 8086, we have a 6-byte long queue. Is it clear?
Yes, sir.
Is it clear to all of you?
Yes, sir.
This is the first thing. Next, point number 2. This is called point number 1 is basically pipelining architecture, which is a advantageous with respect to 8085 and 8086. What is the clock frequency of 8085? 3 to 5 megahertz. Okay.
Yes.
And the clock frequency, of 8086, this is for 8085. And in 8086, 5 to 10 megahertz. Okay. Is it
Yes,
clear?
sir.
Yes, sir.
So in 8086, this is 5 to 10 megahertz, and in 8085, it's 3 to 5 megahertz. So if clock frequency is higher, means, increased, that means it's faster with respect to 8085. Okay. Now point number 3, what will be the address bus? (16-bit). In 8086, the
Yes, sir.
address bus is 20-bit. Okay.
Yes, sir.
So what are the memory capacity? Memory capacity. What is the memory capacity? (64 kilobyte. Memory
Yes, sir.
capacity over here, 1
1 MB.
1 megabyte.
Hmm.
Point number 5. At data bus, what is the capacity of data bus?
8 bit.
8 bit. Over here, data bus is 16 bit.
16 bit.
16 bit.
These are the advantage of 8085 it's have, right? But there is a big problem for related to this address bus. It's a big problem. What is the problem? I will be explaining. First, I talking about the register. I talking about the register. How many type of registers in 8085? 8086. How many type of registers? Registers in 8086.
8.
There are several types. Number 1, general purpose register. Number 2, offset register. Number 2, offset register. Number 1, general purpose register. Number 2, offset register. Right? What are the general purpose registers? Number 1, AX. Number 2, BX. Number 3, CX. Number 4, DX. AX, BX, CX, DX. Okay. And offset registers. Another is segment register. Sorry, this is number 3. Segment register. There are 4 segment register: CS, number 2, DS, number 3, SS, number 4, ES. Full form: code segment, data segment, stack segment, extra segment. Code segment, data segment, stack segment, extra segment. Right? Offset registers. Number 1, SI, number 2, DI, number 3, SP, number 4, BP, number 5, BX. So BX are in a 2 place, one over here means general purpose register as well as in offset. Basically, it is a same register but used in both the purpose, means offset storage
Okay,
as well
sir.
as general purpose register. Is it clear?
Yes, sir.
Yes, sir.
Next,
স্যার ডেটা সেগমেন্টের পর একবার কি বললেন?
code segment. CS is a code segment. DS is a data segment. Data segment. SS is a stack segment, and ES is the extra segment. So code, data, stack, extra. Code, data, stack, extra segment. S for segment. ACGMENT segment. Segment register. So what are the purpose of segment register? What are the purpose of offset register? And what are the purpose of general registers? It's a very important. General purpose register is mainly used for any arithmetical and logical operations. For any arithmetical and logical operations. For general purpose register, right? It's clear?
Yes, sir.
General purpose register basically used for any kind of addition, subtraction, multiplications like that. What are the purpose of segment registers? Segment register is used to to generate the address, to generate the physical address, a segment and offset. With the help of segment and offset, we will be generate the physical address. We will be generate the physical address. So what are the physical address? Sir, in 8085, what are the address? It is a 16-bit address. Am I right?
Yes, sir.
Some 16-bit some 16-bit register also there, like BC, DE, and HL. Three are register pair. Rather than that, there is a PC is a program counter, and another is a
Stack pointer.
SP is a stack pointer. So 16-bit address can be located by a 16-bit register, right? Over here, all the registers are nothing but a 16-bit wide. All the registers are 16-bit wide. There is a no 20-bit registers available in 8086. Problem is, you know, in 8086, address is 20-bit wide. But, you know, in 8085, address bus is 16-bit wide. Is it clear? Is it
Yes,
clear?
sir.
Yes.
So address bus is 16-bit wide, but over here is a 20-bit wide. So that's the biggest problem to generate, to locate any 20-bit address by using the 16-bit address, 16-bit register. So if I'm talking about the AX is called 16-bit accumulator, where higher portions of AX is called AH and lower portion of AX called AL. What is a BX? BX also is a two-part. One is called BH, another is called BL. Okay. BX also is, as a general purpose register as well as offset storage. CX is called by default counter. It's also dividing into the two parts, CH and CL. C higher and C lower. And the last one, that is a DX, used in implicit operations. It is the DH and it's the DL. Okay. This DH, CH, BH, AH, how much bit?
Sir, each AHBH, 8 bit.
8
8
bit.
bit.
8 bit. All are
8
8
bit,
bit.
sir.
8 bit, 8 bit, 16 bit. 8 bit, 8 bit, 16 bit. 8 bit, 8 bit, 16 bit. 8 bit, 8 bit,
16 bit.
8 bit, 8 bit.
16 bit.
Okay.
Yes, sir.
So how the physical address is generated is very important. Physical address, I create a formula. For 8086, you can read the book of Bhurchandi, not Gaonkar. It's available in Bhurchandi. Bhurchandi book you can read, but from my side it's not required if you are follow my class. So physical address is nothing but a segment address into 10H plus offset address. Physical address is equal to segment address into 10H plus offset address. So what is the meaning? Segment address means content of any kind of segment register, and offset address is nothing but with the content of any offset registers. Now, Shubhra, can you tell me your best friend in the class? Okay, leave it, Shubhra. Not for you. Jyoti, can you send me, tell me one name, which is your, your best friend in the class?
So my best friend in the class.
Class or, outside the class, no issues.
Shubhodip.
Shubhodip is your best friend, right? Very good. So Shubhodip, there is a lot of, student is there. Out of that, you chosen only the Shubhodip. Why? Because some frequency or something is matching with you and Shubhodip. That's why you people making friend. Am I right?
Yes, sir.
Yes, sir.
Similarly, these these segment register and offset register are not with each other. It will be, some pair is there. What is the pair? If I'm talking about, like, this is the formula of generate the physical address. Remember, CS. Sorry, there is another register. There is another register. Name is IP. Instructions pointer. SI is a source index, DI is a destination index, SP is a stack pointer, BP is a base pointer, and IP is a instructions pointer. Source index, destination index, stack pointer, base pointer, and instructions pointer.
Yes, sir.
Okay, sir.
So CSPR with always with IP. This is number one. Next, data segment. Pair with SI, DI, and BX. Okay.
Mm.
Third, SS. SS will be the pair SP and BP. Number 4, ES. ES pair with DI and BX. Over here, direct also there. Over here, direct also there. Okay. Next, my question is. What is the function of CS, DS, SS, ES, and what are the requirement of that? CS is basically code segment. If you want to write the program, you always write with CS and IP. If you want to write the program, you always write with CS and IP, right? If you want to store input, output data, then always DS with any other offset register like SI, DI, BX, or direct. Direct means you can give any direct data. SS means stack pointer. If you want to store the stack data, you want to store the data into the stack. So always SS with SP or BP. SP or BP. ES is called extra segment. When data segment is filled up, then extra segment will be worked as a data segment. Extra segment will be worked as a data segment.
Data segment.
Right? Extra segment
Yes,
work
sir.
will be data segment. So that is the function
Mm.
of this one. Next, physical address generation. I already given the formula. I'm not going into deep today
Segment address
because
between.
attendance is not good for today. I will be explaining you from the physical address, from tomorrow. And
Okay.
those people are not coming today. Please ensure that they should come in a tomorrow.